Okay. So we have one last topic, that is the simultaneous information and power transfer, SWIPT. So this is another 6G or 7G technology. Let's say the basic motivation for this is there are a lot of energy sources around us. Like say we are, even now we are exposed to the base station, the signals that is being sent from the base station, and the heat that is generated by the light, and the vibration that is happening within us. Those things are the source of energy. So how we are going to harvest it? Okay, basic, particularly this electromagnetic waves that is coming out of the base station. Okay, so if we could be able to harvest that energy, and if we could be able to power up some devices with that minimal amount of energy, then that is well and good, because that is something that is required. Wirelessly, we want to power something. Okay, that's why we said less energy consumption. So this is the basic motivation of SWIPT, and we could see that both energy harvesting and the information decoding happens. Okay, some symbols are sent for energy harvesting, and some symbols are sent particularly to transfer the message. And even with that message signal itself, there is a possibility harvesting the energy. We know how a information receiver works. Okay, generally, how an energy receiver works. These are all some mathematics behind that. You could see a diode, nonlinear device is connected, followed by a low pass filter. So whatever message that is coming in, it will go inside the nonlinear device, and it will be coming out of this low pass filter, so that we will be having a DC voltage that is that will be coming out, and that will be used for a battery, because this whatever this diode nonlinear device that has been connected, that will do some mathematics as it is given here. You could see, okay, there are some kind of expansions are also there. Okay, so after putting a low pass filter, we will get only the DC power, and that can be used for charging the battery. Okay, so this is how the energy is being harvested in the receiver. Okay, so these are all some of the receiver architecture. Separate receiver can be used for energy harvesting and information decoding, and we have time switching architecture. For a particular amount of time, it will do the energy harvesting, and for the particular amount of time, it will do the information decoding. And power splitting architecture. So a part of a power will be used for energy harvesting, and a part of a power is used for information decoding. Okay, so there will be a trade-off, and we have antenna switching architecture. Alternate antennas are used for energy harvesting and information decoding. Okay, so we have such receiver architecture designs for SWIPT, and theoretically we could see that power splitting has a best trade-off between the information rate and the energy harvesting. Okay, so this is the one I try to convey throughout this session. And this UAV means unmanned aerial vehicle. That is a kind of drones. The wireless drones which carry the base stations can be also used for the wireless communication. Since millimeter wave is something that requires this line of sight thing, they are in a requirement of UAVs. So how the millimeter wave and UAV are integrated, that is shown in this figure. Okay, you could see some lower altitude drones are being used, and higher altitude drones are used. Okay, so with this, I would like to end my lecture. And yes, please, questions, please.
Thank you, sir. Participants, if you have any questions, you can raise now. Surendra sir, please share your mail ID in the chat box, so that for further interactions they can contact you.
Yeah, sure, ma'am. Sure, ma'am.
Yes, sir. Yes, sir. Yes, sir. Thank you, sir. Thank you so much. Thank you, dear participants. Now we'll end the second session of day 4 of this FDP. And tomorrow, as usual, we have the first session at 10 a.m. and the second session at 1:30. And one slight change here is that we are swapping the sessions because of the unavailability of the